Alright, so this video is going to be part 2 of finding equations for lines in 3 dimensions, okay? So the question here is, at what point does the line that passes through the points 1, 0, 2 and 2, 3, 5 intersect the xy plane? Okay, so first off, let's get a better idea of what we're trying to find here, okay? We have our three-dimensional plane, okay? We have or a three-dimensional graph, x, y, and z, all right? And our xy plane is this little guy right here, okay? And that, of course, goes on and on, all around, whatever. But for our xy plane, we want to find where some line goes right through it, all right? And, well, what do we know about the xy plane? Well, what is the z-coordinate on the xy plane? It's 0. Okay, so that's what we can use to find at what point the line passes through the xy plane. Okay, so that's what we're going to try to do here. Now, we need to find an equation for this line. Okay, we need to find an equation for this line, and well, what do we need? Okay, we need a point. We have 2 points, but we need a direction. Okay, we need the direction that this line is moving in, and we have 2 points. We don't have that vector. Okay, so what we need to do is make that vector. Okay, if this line is crossing through 1, 0, 2 and it's crossing through 2, 3, 5, well, let's find a vector that goes from this point to this point. Okay, so anyways, we're gonna do that by just we'll do vector 2, 3, 5. Okay, we'll do this position vector minus this position vector, 1, 0, 2. Okay? For those of you that are unfamiliar with a position vector, it's literally just a vector that starts at the origin, okay? And it just points to some point. Let's call this 1, 0, 2. Okay, that vector would be vector 1, 0, 2. Okay? Anyways, we can see that this is equal to, well, 2 minus 1 is going to be 1. We have a 3 minus 0, that's going to be 3. And we have a 5 minus 2, that's going to be 3. So we get 1, 3, 3. Okay, so now we have a direction, okay, and we have, well, let's use one of these points. Let's use 1, 0, 2. Okay, that'll be our point. It doesn't matter which one we take, but let's just take that one. Okay, so remember our vector equation, okay, off of y equals b plus mx in 2 dimensions to vector r equals vector r naught plus t times vector v in 3 dimensions. Okay, this is our vector equation. Now, if we plug in the position vector for the point on the line that we know, and the vector that's giving us the direction of the line, okay, we get r equals that position vector for the point that we know, 1, 0, 2, plus our parameter t times the vector that gives us direction 1, 3, 3. Okay? So now, okay, this r, we know that's x, y, z. Okay, that's going to be some point that's on our line. Okay? And what determines that? Well, it's going to be this t right here. We're going to plug in different values of t and get different points that are on our line. All right? So, now, if we started, let's do some scalar multiplication here. We get 0, 1, 2 plus, well, we have, when we do our little multiplication here, we get t, comma 3t, comma 3t. Okay, just putting that t through this vector. Okay? Now, before I move on to the next line, okay, of just adding these 2 vectors together, what good is this even going to do us? Well, we know that z, okay, what I said earlier is that we know that z equals 0 on our xy plane. Okay, so that parametric equation with our z equals whatever, okay, it's going to be 0 equals, and we're going to figure out whatever t is, okay, and then we're going to use that t to find our point. So you're going to watch this in a second. We have x, y, 0 equals, let's add these 2 vectors together. We get a 1 plus t, comma a 3t, comma 2 plus 3t. Okay, so the z component on this side will equal the z component on the other side. So we're going to get that 0 equals 2 plus 3t. And when we subtract 2 on both sides, we get that negative 2 equals 3t. And when we divide by 3 on both sides, we get that t equals negative 2 over 3. So that is the t value that gives us the point on the line that is on the xy plane. Okay, so we need to figure out that point though, because it's asking at what point. We're not just going to give them t equals negative 2/3. We're going to plug that in to our line equation, okay, our vector equation for a line, and we're going to figure out the point. So we get that r is now going to be equal to this 1, 0, 2 plus, it's actually going to be, let's do minus 2/3, and then our vector is, where is it, 1, 3, 3. All right, so the first thing that we're going to do, we're going to do some scalar multiplication here. We're going to put this negative 2/3, or actually we can just put the 2/3 through this 1, 3, and 3. So we get r is equal to the vector 1, 0, 2 minus the vector 2/3, comma 2 over 3 times 3 is going to be just 2. And then we get 2 over 3 times 3 again, going to be 2. So let's start doing this out. Vector r is equal to, we have a 1 minus 2/3 there. That's 1/3. 0 minus 2 is negative 2. And we have a 2 minus 2 is 0. So what we just found here is not our answer, okay? This is a position vector that is going to point to our answer. It's pointing to that point, okay? So this is representing a vector, and where I'm about to go with this is not at all accurate. Okay, where I'm about to go with this vector. Let's say that it goes this way, okay? This vector is this, right? Well, let's say 1/3, negative 2, 0, okay? And this point right here, it's pointing to this point that is 1/3, negative 2, and 0. All right? This point is your answer, okay? So don't circle this as your answer. Okay, that's a position vector. It's not a point. Your point is what this vector points to. And since it's a position vector, it starts at the origin, okay? Literally it's the same numbers, but now you put in parentheses and you don't get a point off on your test, okay? So just make sure not to make that mistake, okay? That's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for vectors and the geometry of space, the explanation video for equations of lines in 3 dimensions, and the next video in the series. Lastly, if these videos are really helping you, consider supporting me on my Patreon, which I have linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.